Hey, we have on the board the integral of cosecant 2x minus cotangent 2x dx. Your first thought could be to split this into two integrals, and these are both well-known trig functions that are easy to integrate. But what I wanted to do is try to simplify this first and try to combine these two functions and see what we come up with. First, I'll rewrite this in terms of sine and cosine functions. I think we'll just be a little more comfortable, so we'll write cosecant as 1 over sine 2x, and cotangent's going to be cosine of 2x. Then you'll notice it's pretty convenient. We've got the same denominator, so we can actually combine these two fractions and rewrite this as 1 minus cosine 2x over sine of 2x dx, which I like to forget. Next, what we can do is use the double angle formulas for sine and cosine to write these in terms of just sine x cos x. So for sine of 2x, we have this nice formula, 2 times sine x cosine x. And then for cosine 2x, you may be familiar with cosine squared x minus sine squared x, but we're going to use this other form, which is 1 minus 2 sine squared x. And you'll notice it's easy to go from here to here because you could just plug in right here 1 minus sine squared x, and you get back to this one. So then we'll plug this in and rewrite this. So we'll have 1 minus, for cosine 2x, we'll plug in this 1 minus 2 sine squared x all over, and then we had sine 2x, we'll plug in this piece. So we'll have 2 sine x cosine x dx. Then we're just going to distribute this minus sine and simplify the numerator. So 1 minus 1 is going to be 0. Distributing here, we're going to have just positive 2 sine squared x in the numerator, and we'll have 2 sine x cosine x in the denominator. We can cancel 1 sine x, and we can cancel our 2's. We're left with sine x cosine x, but that's just going to be tan of x dx. And this is a very well-known integral, but we'll just do it out real quick, but we'll put it back in terms of sine and cosine. I can do a u substitution. We'll call u cosine x, we'll say, and then du is going to be minus sine x. I'm just going to pencil in a negative there and then put it up front so that we're not changing the expression. Then I think we'll finish this over in this direction. So we'll have minus, make our substitution, we'll have a du in the numerator and u in the denominator, but this is just going to be minus ln of absolute value u. But I think what I'm going to do is I'm running out of room, we'll substitute that back in, so it's going to be cosine of x plus c. But this is not usually the form we like to see it in. We can take this minus 1 and put it in the exponent here. But if this is cosine x to the minus 1, that's the same as secant, because 1 over cosine x is secant. So that will leave our final answer as ln absolute value secant x plus c.